Hey everyone, in our last video, we broke down how the horizontal oscillation shader works in raw WebGL, how a sine wave pushes pixels left and right to create that smooth, wavy distortion you've seen in classic EarthBound battle backgrounds. If you missed that one, check it out first, the link's in the description. Today we're jumping straight into how to bring that effect to life inside Phaser 3. If you'd like to follow along, I've included a link to the starting code in the description. Download it, open it up in your editor, and let's get started. To make things easier, I prepared a starter project for you. This project already has a lot of the boilerplate code done. It loads our assets, renders a background image, and even includes a simple pipeline that just displays the image. That way, we can focus purely on adding and tweaking the horizontal oscillation shader. Let's take a quick look at what's already in the boilerplate. In our public folder, this has all the assets we'll be using for this example. Our source folder, this has all of our Phaser code. Our main.ts file creates our Phaser game configuration, adds a few Phaser scenes, and then starts our game. Under our scenes folder, our loading scene, this scene is responsible for loading all the assets we'll need for our example. After our assets are loaded, we transition to our game scene. So in our game scene, we set up our shader pipeline, we render out a background image, and then we create a Tweakpane integration. Our Tweakpane integration, this is going to allow us to modify our values that we pass to our shader. Finally, we have code for rendering out our sine wave that we're going to apply to our texture. Our Tweakpane integration is currently set up to modify the settings on the sine wave. So in our game scene, everything is ready, so we can jump straight into adding our horizontal oscillation effect. So under our source, our shaders folder, this is our custom pipeline that we already have set up. Right now, it's just a simple pass-through shader. It displays our image as is. On our custom pipeline, we expose a few properties for our speed, our amplitude, and our frequency. We have setters that will allow us to modify these values from our game scene, and these are currently connected to our Tweakpane integration. Phaser 3 makes it easy to use custom shaders through its pipeline system. To use our pipeline system, we create a custom class that extends our built-in Phaser PostFX pipeline. And with our pipeline system, we can apply this shader to one of our game objects. To use our pipeline, we first have to reference our renderer on our Phaser scene. From our renderer, we can then reference our pipeline manager and then add our PostFX pipeline. Once we told the renderer about our pipeline, we can add this to any of our game objects. So for our background image game object, we're adding in our horizontal oscillation pipeline to that game object. When we render out our background image, all our shader does is take in our original texture's pixels and render them out. So now for our shader code. For our horizontal oscillation effect, we first need to add a few uniforms that will pass to our shader from our pipeline. Our key uniforms that we'll need is our time, so how much time has passed since our shader has started running, our amplitude, which will control our wave height, our frequency to control our wave shape, and finally, a uniform for speed, which will allow us to make our wave faster or slower for our animation. So now to add in these uniforms, inside our fragment shader, outside our main function, we want to use our uniform keyword. For all these uniforms, these will be floats. We'll have our uTime. I'm going to copy this line of code. We'll paste it 3 more times. So we'll have our uSpeed, our uAmplitude, then our uFrequency. Now that we have our uniforms, we need to update our pipeline to set these values. So in our custom pipeline, we can do this on our onPreRender method. Our onPreRender method is going to allow us to update these uniforms for each frame of our game loop, and then our wave will animate in real time. Because this is running entirely on the GPU, it's super efficient, so perfect for real-time games. So to set these uniforms, we want to do this to reference our pipeline. We'll use the set1f method. This method allows us to provide our uniform name and the value we want to pass. So first we'll do our uTime. For this, we'll want to grab the amount of time that has passed in our game. So we'll do this, we'll do our game instance, we want to grab our loop, then our time value, and we'll convert this to seconds, so we're going to divide it by 1,000. So now we need to do our other uniforms. We'll copy that line of code. Now we'll do our uSpeed. So for the rest of our uniforms, we're going to reference our properties that exist on our pipeline. So we're going to do this, then we'll reference our speed. We'll copy that. We'll paste it 2 more times. And now we want to do our amplitude and our frequency. With our uniforms in place, now we need to add our actual shader code. Now for our shader, we just need to implement our horizontal oscillation effect. So we'll reuse our code from our other video. So first, we need to create a sine wave that's going to vary along our vertical or our y-axis of our texture. So for that, we're going to make a new float, we're going to call it wave, and then we're going to use our sine function, and then we're going to use our y-coordinate of the pixel we're currently evaluating, then we'll multiply it by our frequency value, and then add in our offset for our animation by using our time and multiplying it by our speed. We then need to calculate the horizontal offset for our current pixel. For that, we'll make a new float, we're going to call it offset, and then we'll do our wave float times our amplitude uniform. Once we have our offset, we just need to create a new vector 2 that represents our coordinate we're going to look up from our texture. So for that, we'll make a new vector 2, we're going to call it new coordinates, and then for our vector 2, we want to take our x position of our pixel we're currently looking at, and then add in our offset. For our y value, we just want to use our original y position. Then finally, we need to use this new coordinate to sample that position from our texture that's been passed in. To do that, we're going to use our GL frag color. We're going to set it equal to our texture 2D. We can sample from our texture, and now for our texture we want to use, this is going to be our uMain sampler. So this will be our main texture that's been passed to our shader. And now for our position, we want to use our new coordinates that we just calculated. Finally, we just need to update our reference for our pixel that we're looking at. So instead of this being called UV, we're going to use our out text coordinate. Now if we save and we come over to our browser, we should see our new effect being applied to our background image game object. And that's all there is to it. With this setup, we can easily tweak the wave parameters using Tweakpane and immediately see the effect on our background image. And the best part, you can use the same shader for all sorts of cool effects, subtle water ripples, trippy battle backgrounds, or just adding some retro flair to your scenes. If you want a deeper dive into the math behind the shader, check out the first video, links in the description. Thank you so much for watching. If you found this helpful, hit the like button, leave a comment with the shader effects you'd love to see next, and don't forget to subscribe so you won't miss future phaser tutorials. And if you'd like to support the channel, I've got a Ko-fi page, the link's in the description. Every coffee helps me keep making these videos. See you in the next one.